Welcome back. Let us quickly review what we learned from the Celsius temperature scale and the measurement technique involved. First, we notice that we had defined a system, the liquid in glass. This was our thermometer, the measuring system. It was a rudimentary system, but more important for us was that it had just one property which could be used to label isotherms. So that property could easily be mapped to the temperature. Second, we needed fixed points. In this particular case, we had the ice point and the steam point. And for this, apart from this system, a fluid, ice, water, steam, was also used. Then we assigned arbitrary values to fixed points. For example, we set the ice point temperature, let it be 0 on our Celsius scale, and let the steam point temperature be 100 on our Celsius scale. And finally, to determine the temperature of a system, if the temperature lies between 0 degrees C and 100 degrees C, we had an interpolation law or an interpolation scheme, a relation or an equation. Now, what are the problems with this? First thing, you will notice that there are a number of issues here. First, we have to define a system. So the scale depends on the definition of the system itself, here the liquid in glass thermometer. It will also depend on the fixed points and the material used, water in this particular case, to define the fixed points. Third, the values given to the fixed points. For Celsius scale, give the values of 0 degrees C and 100 degrees C. So between these two limits, if you interpolate, the temperature will turn out to be on the Celsius scale. And again, an interpolation scheme, we assume that, look, let the temperature be represented as a linear scale or a linear function of the mercury thread or the liquid thread length, the capillary, in the capillary. Anything you change among these and you will get a different, distinctly different temperature scale. For example, instead of the ice point being 0 degrees C, we may decide it to be 50 degrees C, 50 degrees new Celsius. Steam point could be 475 new Celsius scale. We will get a new Celsius scale, nothing wrong in it. Another scale which is very similar to this is the Fahrenheit scale. And for the Fahrenheit scale, the ice point is 32 degree Fahrenheit and the steam point is 212 degree Fahrenheit. Very similar to this, just a difference in the definition of ice points, and of course a corresponding change in the interpolation scheme. Now, if temperature is a basic thermodynamic property, then the value should not really be dependent on a scheme which requires so many arbitrary things to be fixed. And because of this, over the years we have had a Celsius scale, we have had a Fahrenheit scale, there was a Römer scale, and I don't know how many other scales were proposed, and many of them must have got rejected. Today, the two common regular scales are the Celsius scale and the Fahrenheit scale. Another restriction when you use a liquid in glass thermometer is the fluid which you use. If you use mercury as the capillary fluid, then it is perfectly okay to use it between 0 Celsius and 100 Celsius. You could even extrapolate it a bit For example, mercury freezes at approximately minus 40 degrees Celsius, 40 degrees C below 0 degrees C. So mercury will freeze, it will not be a liquid anymore. So you can't measure temperatures below minus 40 degrees Celsius. Mercury boils at approximately 335 or 336 degrees Celsius. And once it boils, it will form a vapor. The space above the capillary, space in the capillary above the liquid thread will not be a vacuum anymore. Pressure will build up, the thermometer may crack, and hence it is recommended that you do not use mercury in glass thermometer at temperatures say above 300 degrees C. If you replace mercury by some other fluid, we will be restricted by its freezing point and its boiling point. But as science improves, as technology improves, we need to measure lower and lower temperatures. Today measuring temperatures up to minus 80, minus 100, minus 200 degrees Celsius is routinely done in many industries and many laboratories. Similarly, now we have combustion processes and other high temperature processes where the temperatures goes as high as 2000, 3000, 4000 degrees Celsius. Ordinary liquid in glass thermometers cannot measure such a wide range of temperature. Hence, scientists and people interested in thermodynamics and in thermometry were always looking for different ways of measuring temperatures over a reasonably wide range, as wide as possible. That brought them to gas thermometers. Thank you.